Have you ever tried fitting books into a bookshelf, only to realize not every book fits perfectly? That's exactly how fixed partitioning works in computer memory. Let's first understand what fixed partitioning means. Fixed partitioning is a memory management technique used by operating systems. It divides main memory into fixed-size blocks, called partitions. The partitions can be unequal in size or equal in size, depending on how the system is designed. Each partition can hold only one process, and the size of these blocks doesn't change. Now, let's make this even easier to understand by comparing memory to something we all use, a bookshelf. Think of main memory like a bookshelf, and each shelf is a partition. Let's see how this works and what problems it creates. This small 4 MB shelf fits a 3 MB comic book perfectly. But look, there's still 1 MB of empty space we can't use. This is called internal fragmentation. Only one book per shelf, no matter how much extra space remains. Our large 16 MB shelf stores a 15 MB encyclopedia. Another 1 MB sits empty and unused. Rule: if a book is even slightly too big, like 17 MB, there's no room for it at all. Don't worry, dynamic partitioning solves all these problems. Unlike fixed partitioning, dynamic partitioning creates memory blocks tailored to each process's exact size. Imagine a bookshelf, where shelves magically adjust to fit any book. No wasted space, and no internal fragmentation. But what happens when you remove a book? Gaps may form. This is external fragmentation. Over time, small gaps make it hard to fit new books. Solutions like compaction, rearranging books, can help. Compaction rearranges all books to merge the gaps into one large usable block. But compaction isn't free. It takes time and CPU power, like reorganizing your entire bookshelf. Compaction fixes fragmentation, but it's slow and disruptive. A smarter solution? Placement algorithms. First fit, next fit, best fit. First fit checks each shelf in order and picks the first one with enough free space. Next fit remembers where it last placed a book. Let's call it a bookmark. When a new book arrives, next fit starts searching downward from the bookmark, not from the top. Best fit doesn't just grab any shelf that fits. It hunts for the tightest possible fit, where leftover space is tiniest. These placement algorithms help manage gaps in dynamic partitioning. But how does this compare to the older fixed partitioning approach? Let's examine both. Fixed partitioning pros: fast allocation, no search overhead. Predictable for real-time systems. Cons: internal fragmentation. Unused space within partitions. Inflexible. Large processes fail if partitions are too small. Dynamic partitioning pros: no internal fragmentation. Efficient for variable process sizes. Cons: external fragmentation. Free memory becomes scattered. Overhead. Requires placement algorithms and compaction. In summary, while dynamic partitioning dominates modern systems for its flexibility, fixed partitioning still serves critical specialized roles. Thank you.